Vos assistir.
Hello everyone, today we are going to present our project about turning combustion into electricity. So, the work, this is our index, the topics that we are going to talk during this presentation. So let's get started. The work presented here aims to demonstrate a strategy that allows us to reduce one of the bigger problems nowadays due to its global impact: the use of fossil fuels to obtain energy. Currently, the dependence of world energy matrix on non-renewable energy sources causes reserves to decrease due to the intensive and uncontrolled exploitation of natural sources. Also, the emission of gases causes the greenhouse effect that must be taken into account, since the burning of fossil fuels reduces a high amount of carbon dioxide that intensify this effect and causes of climate change. So, let's continue.
Now, the development. It is known that nowadays exists a high spectrum of processes that can turn biomass into energy. We have here the thermal energy, the electrical energy, and the mechanical energy. These ones we only are capable of using this type of energies because the evolution of the technology along the years. In this work, we are using the thermal energy as our source because it's one of the most used ones in the globe, because it's easy to use and it's very reliable.
So, what is combustion? Combustion, as already mentioned, is the technology most used in the heat production and consists of the chemical reaction of oxidation, which occurs between two substances that generate heat as a way of realizing energy. This phenomenon is common in our daily lives, but only occurs when these three factors are present: the fuel, the oxidizing, and the ignition source. And the result of the reaction between the fuel and the oxidizer is the first step in order to produce energy through this method.
The energy. This doesn't come out of nowhere, and unlike combustion, it cannot be exactly defined. But, however, we can say that energy not only has the ability to produce, but also the ability to act or move, manifesting itself in different ways. Our project is the combination of these two concepts, combustion and energy, where one will be originated by the other. So, let me just take this down. So, this was a kit that we bought all the materials and we built. This kit is composed by a Peltier ceramic cell that is inside here, and it's like this. We also have a heat sink that is down here. We are going to talk more about these things more in front. A thermal insulation for the cell, a fan with grid that is up here, and a thermal paste that we put on the Peltier ceramic cell. This kit has a maximum power of 60 watts, a voltage of 15.2, and a max temperature of 225 degrees Celsius. And for this project, we also need a filter, a hose, and a LED light.
Okay, now the next slide will contain more information about the components that my friend Wuzu was talking about. For the first, we are talking about, I'm going to talk about the Peltier tablet, that I think is the most important piece of our work, because we have done the work around it. The Peltier tablet is a device that follows the Peltier theory, let's say if you eat this side of the tablet, the other side will be freezing. So it's commonly used in mining stations of Bitcoin and cryptocurrencies. But in this work we are using it in a different way. We are using the feedback theory that it's the same that the Peltier one, but we are using it not as a temperature regulator, but as a power source.
Now we have the heatsink. So the heatsink is connected to the semiconductor board. We put with glue and here provides an efficient way to transfer the internal heat of the component to the environment, and was built in a way that reduces the junction temperatures, preventing the semiconductor from burning out. This is used to preventing the peltier from burning out and exploding. Next, we have the fan. It's used to maintain the thermal sensation, in other words, the heat, and even when the temperature goes down, forces it to its initial temperature. The thermal isolation limits the heat losses and exchanges from the outside of the peltier tablet. It isolates the peltier tablet from heat when it overheats and from cold when it cools down. The thermal paste that we put on the cell is responsible for keeping the temperature of the tablet as low as possible. It's characterized by being a viscous liquid, and it's applied on the surface of the tablet, acting as a conductor of the heat to be dissipated by the heat.
Now about the filter. Initially, our idea was to replicate the filters of the company Climeworks that have the ability to capture carbon dioxide in two steps process. In the first, the air is sucked into the collector with the fan. Next, carbon dioxide is captured on the surface of a material that has a highly selective filter inside the collectors. The second step occurs after the filtering material is filled with carbon dioxide. When this occurs, the collector is closed, and the temperature is increased between 80 and 100 degrees Celsius. During this process, the carbon dioxide is purified so that it can be collected and used. Now I want to show you one video explaining.
This doesn't have sound? Sorry. It's not coming out.
Yeah.
The sound not coming.
Esse som, como é que vocês ligaram o som do vídeo? Já não vi. Aí estão à frente, não é?
Está ligado aqui.
Vais ver lá se está nas planas certas.
Hã?
Claro, tens que ver se está nas planas certas.
Já não era preciso ligar mais nada ali à frente. Quem é que outra vez teve este problema?
Supostamente é preciso assim, ligar aí do lado.
Era do lado, não era?
É do lado, não estou no meio. Isso. Supostamente é isso.
The air is drawn into a collector with a fan, and CO2 is captured on the surface of a highly selective filter material that sits inside the collector. Next, once the filter material is full of CO2, the collector closes and is heated to around 100 degrees Celsius. Using the carb fix method, the captured CO2 is then mixed with water and pumped deep underground, where it mineralizes and can be stored permanently for thousands of years.
So that you can get an idea of the currency of this company is, an assessment that is independent of life cycle shows that the ash emissions from these machines are below 10%. That is 100 tons of carbon dioxide that are caught in the air, 90 tons are permanently removed, and only 10 are pursued. However, the filter we ended up using in our project was one suggested by teacher Isabel. This consisted of the use of sponges on the top of the box This would have the function of absorbing carbon dioxide and polluting gases, creating bubbles. The only problem that could be raised in the use of this filter was the constant spinning and necessary washing of the sponges.
This,
How you can see.
yeah, these are sponges.
Now the question above is, where is CO2 placed? After being purified and stored, the carbon dioxide can be used, for example, as sustainable aviation fuel, or in soft drinks, or sold to the greenhouses. However, in the case of Climeworks, they store the CO2 in geosphere, as this is the most permanent way of storage. How you can see in the photos, this is where Climeworks store the CO2. For the project to be put into practice, several tests were needed to reveal what was or was not possible and what would have to be changed for it to be successful.
Now, the LED lamps. Our idea is to recreate a self-sustainable city. So we needed to have lights, and the LED lights, or the LED lamp that we use, is the most efficient and is the most efficient way because it's a low cost and is easy to use. Now, our project, what is the definitive thing that you want to talk about? Like I mentioned in the early slide, our goal is to create a self-sustainable city that could use daily wastes like food as a source of energy to power the lights and in general everything. So we built this box where we wanted to we wanted to use the trash, the daily wastes as a fuel to light a fire, so we can heat up the Peltier tablet and use it as a power source. And with our filter, any waste of any type of residuum that was going to be expelled to the atmosphere was going to be filtered. In this way, we could use the trash and the waste as in a positive way. So the sponges are here to absorb, like my friend Hugo said, the CO2 emission. And later we wanted to transform this energy to domestic energy.
So these are the test materials that we had. So we have two digital potentiators. We just have one here, but one is used to see the voltage and the other to see the temperature. We use also a LED lamp. That was replaced by incandescent lamp because we talked with the teacher that said she gave up of LED lamps because they are practically impossible to light up. So we use also a claw to support our cell on the tests and for Peltier cells. We just have two now because one is here, the other exploded, but yeah. So what went well and what went wrong? So on the positive side, we have the house. At the beginning, we had low expectations with the house, but after the final project was made, it expected all our expectations. The ordered material come all in good state, and after the conference we held, that should be noted as it managed to train us by providing us with information to how to improve our project by realizing the mistakes we had.
So, in a negative way, the period of testing our cell was damaged, which made it impossible to continue this test. How you can see, it's burnt. In another test session, one of the incandescent lamps didn't turn on, despite trying various methods to get it to do so. Many of the contacts made were not successful. Initially, the lack of knowledge about what to do with carbon dioxide once it was in the box jeopardized the time that we talked would arrive to finish the project, but this ended up being solved in an alternative way.
So the contacts are made. Initially, we tried a contact with the company Climeworks, but we were not successful. We only got response by automatic responses that doesn't do nothing.
And that's to buy CO2.
Yeah. This company would have been an asset to our project, but with that impossibility, we were lucky to have Professor Fatima, who gave us a brilliant idea. She gave us a contact of a group of professors that gave a lecture on, and one of the topics was how to do energy with combustion. Immediately, we sent a mail and later managed to arrange a meeting where we improve our work by correcting various errors.
Now, for the conclusion of our work, in a short, we wanted to, in a short, this project help us understand the state of the world a little bit more, and help us find some simple solutions that we think that are viable, that could help and improve the state of the world. Because as everyone knows here, we are in a kind of bad spot, I guess. We have a scientist gave us a date where the state of our planet is not reversible, and we are not taking the proper decisions that we should, and kind of being bad boys, I guess. Basically, it is. In relation to our work, we had a lot of problems. First was the shipping. It was kind of late. When it came, it exploded. So we needed to find another way. Then government wanted us to have bigger holidays, I guess. So gave us 10 days, but we needed to be in school to do the project. So we lost a lot of time and ended up not being able to burn things to light up our lights, unfortunately. But we got better as a team, as a whole, and have had a lot of fun doing it.
Yeah.
And I think that is what matters.
Yeah, it's the most important.
Let's show how our project works.
So, the purpose of our project was to have like so the fireplace that pellets, small pellets here that would we would light up. The system was going to start moving and doing stuff. The vent was going to start rotating, and the heat was starting to get more and more power, and all the lights were going to light up and beautiful stuff, but unfortunately didn't happen. And yeah, this is our project, our group, and yeah, we hope you liked.
This is our code names: Cheerful, the Angry, and the Glowing.
If someone have any questions, please make it and we try to make it. That's it. Thank you.
Fogo, ela olhou para aqui. Bom.
Wszystkich student English with Venus.